Hello and welcome back to my channel Elixir with Anoop. So this video is actually a continuation of the Elixir processes videos that I uploaded last week. So let's try and explore something more about the process. Let's try and see how do we kill the process. So here in an example, let's say if the process receives a tuple exit code, it's just going to exit the process. Come back over to the right hand side and recompile it. Let's spawn a process. So I'll say spawn. I'll use the model function argument part. I'll say greet. I'll say 0. Yep. So let's try and crash the process or kill the process. So whenever I send in a tuple called exit and I say it something like, let's say bang. Yep. So it returned me the tuple I passed into send, but it didn't. It did something, but I don't know whether my process has been killed or not. So let's try and test it out. If I send it a tuple, I set the count to 1. Yeah, so the process has actually gotten killed. It's no more, because if you look closely over here, it has not outputted this part. As what it has just returned is whatever we passed into send. So our process has gotten killed, but strangely we did not get any notification or any thing printed to the console that it has gotten killed. So how can we solve the issue? So spawn, it turns out we can use a different version of spawn called spawn link. So spawn link is actually used whenever you want to link the future of a child process to the future of its parent process. So if either the parent or the child process dies, it actually kills the other process. So here, for example, if my child process has died, it actually would kill my parent process also. Okay, so let's try and use that version of spawn here. Let's say I use, instead of spawn, I use spawn link. Yep. So now let's send. So now let's exit the process. Yeah. So you see what happened over here is our process has gotten exited abnormally, so it got killed, which in turn killed the parent process, which is the IEX, and the IEX just restarted itself. So that the restart happened because of a concept called as supervisor. We'll get to know what supervisor is. I'm not going to explain more about it in this video, but hopefully in my upcoming videos I do that. But the important thing over here is our parent process got notified of the fact that the child process died, and it also and it also died along with it, right? So now let's try and exit the process normally or gracefully to see what happens. So if I say it's spawn link demo and I say exit and I send in a code as a normal, yeah. So here so here, as you can see, it just exited the process normally. So the process is no more. We can prove it by just say set count. Yeah, so the process is no more, but our parent process, the IEX, just got notified of it, of the fact that the child process actually got exited gracefully, so it didn't take any action. It's only with the abnormal uh, crashing or termination of the process, the other process gets killed. Yeah, so we can abstract some things out now. So for example, uh, this spawn link part over here, I can actually abstract it into a function. So I can say, let's say new, and I can say spawn link, the module. So if you want to refer the module, you'll say this, and I can say greet, and I can say a 0, and then instead of using the send construct directly, I can use the new. So, and this would return me a PID. Yep, so this returns PID, and then I can actually instead of I can use a function called set. It can take in a PID, and I can say send PID a tuple of set. It takes a PID and a count, and I can say a set count. So I can do all these all these kind of things in order to maintain the state in the process and just interact with the state. So all these things, fortunately for us, we don't have to type send and receive over and over again. Elixir has a nice abstraction for it. It's called the GenServer. One of the most canonical example for a GenServer is actually a stack. So let's create an Elixir file called stack.exs. I'll say def module, I'll say stack. Now the concept of a GenServer is it has syntactically it has two parts. One is the client part and another is the server part. Well, the client part is actually triggered off from the calling process, which in turn will trigger some of the callbacks in the server side. So let's see how it's like happening. So like uh, uh, we'll have a function called start link. Yep. So whenever I say start link, it will say GenServer dot start link. It takes in a module and it takes in a parameter. We are not bothered about the parameter here, so we are passing nil, and what it returns is it returns a tuple. If it's able to create the GenServer process successfully, it returns a tuple called the OK and PID. So we pattern match it out and we return the PID over here. So this is in the client side. Over in the server side, I'll just make a division to sort of distinguish between the client side and the server side. It calls in a callback call init in the GenServer process, right? And actually, whatever we pass over here is actually passed to this callback init. Since we have passed nil, we are not bothered about what it actually passes. So I just say an underscore since we are not bothered. And what it should do is it should create the initial state. It should create the state from the arguments that we pass to init typically. But here I can just say okay, and the initial state, which is just an empty array. So the init function, it should return a tuple called OK and the initial state. Yep. So now that we have the initial state of our gen now that we have the initial state of our gen server, let's try and do some operations on the state. So let's try and push something into the stack. So I'll say pid and a value. So the push is actually just a wrapper over this method called the call function of the gen server. So what it actually does is it takes in a pid, and the same thing that we did in the process example, since it's just an abstraction of it, I can say that it sort of sends a tuple called push and the value. Over here in the server side, we listen to the call function via a callback called handle call. So we have a handle call over here, and we can pattern match this particular thing over here. So if we receive a tuple called push and a value, it takes in the data that you actually call the gen server with, and it optionally it takes in a from argument, so which process actually called it. So this is the pid of the calling process, and it takes in a state, right? So the state over here is this. So what it should actually return, it should return a 3-element yeah, so it should return a three-element tuple called reply, and it should and the value that you return, you should return the return value and the new state, right? And the new state. So it should return a tuple like this. So I will return an OK just to demonstrate that it has actually successfully pushed the value onto the stack, and the new state is going to be added to the current state. So it's going to be just the value and the state. Yeah, just exit. Yep. So let's say that so let's compile it. Let's say stack.exs. Yep. So I can say the pid equals stack dot start link. Yep. And it's a pid, and I can actually push the so now that I've gotten the pid, I can actually push a value onto the stack. So I can say stack.push the pid and let's say 1. Yep. I can push 2, I can push 3. So now the stack should actually have 3 elements in the order like 3, 2 and 1. So how can we actually confirm that? Well, we have a nice tool in Erlang and Elixir called the observer. So I can just say observer dot start, and it will open up a window for me, an application. Here I can actually look at the processes like according to the PID, and then we have the PID as 110. So let's see what 110 is. Yep, so we have this Elixir stack. So let's see, we have something called as a state here. Yep, so you can see this is actually the state 3, 2, and 1. Yeah. So now let's do something more with it. Since it's a stack, I should be able to pop from it also. So I can say pop. The same goes up. So I can just say pid, and in turn what it should do is it should here I can just send in a value. Since it's just one value, I can just send in I can just send in a symbol or an atom called as pop. Over here on the server side, I can say handle call, and I can pattern match this thing out, and this is going to be the state. So now two things can actually happen. If my state is actually empty, I cannot pop from an empty state. So I can actually say a reply or a reply and another tuple, let's say error, and I can say can't pop from empty stack. Yeah. And so and this state is just the state, or else I can say a reply, and if I am able to pop from it, I can just say I can just say head and tail, right? Head and tail equals state, and I can just return the value head, and the new state is the tail now. Yeah. But since it's but I'll just step back and see why I'm doing this. In Elixir, actually, you can uh, instead of using a if and an else, which actually makes this handle call do two things, I can actually pretty gracefully do this. I can say handle call, I can say pop from state where state is equal to empty, and I can just paste it over here. And if it's something else, it's going to say handle call, the same thing, pop from, but this time I can say that it's going to be a head and a tail. So I can just destructure the state into a head and tail, because I know that it's not empty. So I can just say a reply head and a tail. Yep. So I don't need this if and else condition. That's actually the beauty of Elixir. By using pattern matching, we can match on the exact parameter that we are expecting, and then we can write pretty small, concise, and focused code like this. Yep. So let's test it out. So for testing, I can have another method, let's say inspect, that also takes in a PID, and that takes in a PID, and what it does is it just sends a string called, it just sends an item called inspect over in this, over here in this in the server side, just calls a handle call, it pattern matches on inspect. We are not using the from, and whatever the state is, it just returns the same state. So I'll just say it returns the same state, and is this state. Yep. Yep. So let's recompile it. So you can see our stack. Yep, it's recompiled now. Let's clear the mess. Yep. So let's say PID. I can say stack dot start link. Yeah, now I can push values. I can say PID, I can say 1, I can say 2, I can say 3. Now if I want to inspect my state, I can say inspect, I can say PID. Yep, my state is now 3, 2, and 1. So let's pop values out of it. I can say stack.pop PID. Yep, so 3 comes now, 2 will come now, 1 will come now, and now if I try to pop, it will say error. It can't pop from an empty stack. So this was a short introduction of the GenServer and what capabilities it carries. So it's a nice way of abstracting the state and operating on it. So I hope that you like the video. I'll try and bring as much of practical and informative videos on some of the crucial Elixir concepts that I can in my next video. So that's it, guys. Thanks, and do like and subscribe to my channel.